Is negative 1 comma 7 a point of intersection for these two lines? One way to do it is to graph these two lines properly. However, we can also use algebra. We can substitute the x and y values into both equations and see if they match. So let's plug these values into the first equation. Does negative 1 plus 2 times y equal 13? Question mark. So we have 2 times 7 is 14 minus 1 is 13. So the left side equals 13 and the right side also equals 13. Left side equals right side. So we say yes, perhaps this is a point in this system. We know this point is on this line, but it has to be on both lines. So let's not jump to conclusions. We need to plug this point also into this line over here. Let's plug in x equals negative 1 to this right equation. 3 times negative 1 minus y, which is 7. Does it equal to negative 11? Is this point on this second line? 3 times negative 1 is negative 3 minus 7. Does it equal negative 11? The left side is negative 10 and the right side is negative 11. So we say no, this point is not on the second line. So therefore, overall, even though this point is on this line, we're going to say no, it is not a point of intersection. Now let's try the next part. Is point 8, 3, x and y values, a point of intersection for these two lines here? Let's focus on the first line using substitution. We have 2 times 8, that's the x value, minus 4. Does it equal 4 times the y value, 3? The left side is 2 times 8, which is 16, minus 4 is 12, whereas the right side is 12 as well. So yes, this point is on the first line. Now to be a point of intersection, it has to be on both lines. So now let's substitute into the second equation. Does x plus y, does 8 plus 3, question mark, equal 11? The left side is 8 plus 3, which is 11, and the right side is also 11. So we'll say yes, indeed this point is a point of intersection. I encourage you to actually graph these on Desmos and see exactly what's happening. Let's solve by graphing. We have two different lines, here and here. Now by graphing, let's sketch y equals 3. 1, 2, 3. Y equals 3 is a horizontal line that runs with a slope of 0. Y equals 3. Now what about this line here? Using algebra, we have y equals negative x plus 2. We moved positive x to the right, making it a negative x. So the slope is negative 1 and the y-intercept is 2. So let's go up 1, 2 and draw a dot here. Now the slope is negative 1 over 1, so the rise is down 1. So from this point, we're going to go down 1, and the run is positive 1, which means 1 to the right. So we draw a diagonal line. This is like a 45-degree kind of a downhill negative 1 slope going down this way. So what is this point of intersection? So it's pretty clear that here y is 3. So it's going to be something, comma, 3. And because the slope is negative 1, when we go left 1 unit, we go up 1 unit. So indeed, the x value must be negative 1. So solving means to find x, and x equals negative 1. And if the question was to find the xy coordinates, it would be negative 1, comma, 3. Now let's solve by substitution. We're going to substitute this y value, 3, y equals 3, into this y value here. So we have x plus y equals 2, and what is y? 3. So we can see that x equals 2 minus 3. We throw positive 3 over, making it a negative 3. So x equals negative 1. We found the x value, so we solved x, negative 1. And if we wanted to find y, we could substitute either into here, but it's easier just to state the obvious, that y is 3 over here.